Hi. Today we are going to study about the symmetry about a plane. Suppose you have a mirror like this. If there's a point P, it will have its reflection at the same distance from this point of contact. Let it be M. Distance PM is equal to distance P dash M. We say this is the reflection of this point. Take another example. Any point over here, P, draw a perpendicular, extend P dash. So this distance is equal to this distance. We say P dash is the reflection of this point. So reflection is perpendicular distance on the plane with equal distance from the point of contact. This point P, if we draw a perpendicular on this plane, meets at point M on this line or plane. We extend this perpendicular line, take this distance equal over here, the point at which we arrive. This is known as the reflection of this point. Now, if we take the other way around, reflection we have defined about this plane. Now, if you know the reflection of a point, you can say there are many other points also, but this point P double dash is not reflection of P because it is not perpendicular and it is not equidistant from this point of contact. Now, this point is significant on this side of plane because it represents the reflection of this point, or it is significant because it is equidistant from this point of contact on the line that is perpendicular from this point on the plane. Now this point is significant, this point is not significant, other points are not significant because they do not lie on this line, as well as they may not be equidistant. Now P dash, this is a line, that is a straight line. This P dash line is perpendicular on the plane. Then we say this plane is symmetric about PP dash line segment. This is a line segment. It divides it into two parts. This is equal to this. So we say symmetric. This line is symmetric about this line. So the word symmetry or symmetric comes into picture. So basically we want to study whether this line is symmetric or not symmetric on these 2 points or on the graph. If we extend this graph like this, every point on the graph will be symmetric about this axis. So symmetric is and every point on a graph or curve is giving you a reflection at equidistance or is equidistant from the point. We say the plane is symmetric. This is a straight line. Every point P gives you reflection at P dash, Q gives you reflection at Q dash, this is M point. So this distance is equal to this distance. If you take the reflection of this point, this distance is equal to this distance. So all the reflect points that are reflection of the points, they lie on this line. If we see this plane as a mirror, then we say this mirror is symmetric about this graph. This is the graph. So this mirror is symmetric about the graph. Now this is something about the reflection of this point on this lies on the same graph. The reflection of this point lies on the same graph. So we say this mirror is symmetric about this graph. Now symmetry can be like this also. Graph may be like this. Plane is like this. Every point gives you value. Let us say this is giving you value of this point represents AB is the coordinate of this point, and coordinate of it's a reflection. This is a mirror. This is a mirror. A reflection is P dash, and it is giving you coordinate of A comma minus B. Now this is the mirror. Every point on this graph is giving you the reflection with coordinates same, but only y coordinates. If it is 2, it comes as minus 2. If coordinate of y is 3, it gives you minus 3, but coordinate of x remains the same. If this happens, then we say this mirror is symmetric about the curve. But this curve is symmetric about x-axis. X-axis is the mirror. Every point on this curve, they give you reflection that are equidistant from this axis, but y coordinate changes its value to negative. If it is plus 4 on the y side, it gives you minus 4. So this point B, AB, this B will change into minus B, A will remain same, x coordinate will remain same. That means this graph is symmetric about x-axis. So conclusion is, if point P A comma B gives you a reflection of P dash A comma minus B, we conclude that the curve or graph is symmetric about x axis. Now case 2, that was case 1. If you have a graph like this is your coordinate axis, and you have a graph like this. Every point over here, P, maybe like here, anywhere over here, and suppose this is the mirror. You take the reflection, you find reflection of PAB gives you P dash of minus A comma B. B is same. You get every point reflection the same coordinate, but only x coordinate taking a negative sign. If it is here, it is say 2, 5, and here it's the reflection of this point, let us say R. So R dash reflection takes a value of minus 2, 5. Every points giving you reflection of minus of x coordinate, and y coordinate remains the same, then we say this graph is symmetric about y-axis. If P of A B gives you P dash of minus A comma B, in that case we say the graph or curve is symmetric about y-axis. Now case 3. Suppose this is the coordinate axis and this is the point mirror. A point P over here gives you a reflection equidistant P dash, but coordinates becomes minus A minus B. This distance is equal to this distance, but coordinate of P as AB gives you reflection P dash of minus A minus B. In that case, these two are same. I am not saying this point or this point. This point may be having different coordinates, this point may be having different, but same coordinate. A is A, B is B, but with negative. That means first quadrant is giving a reflection in the third quadrant, first, second, third and fourth. So if you get this is a mirror, point mirror giving you a reflection on this direction, same values but negative, then we say this point or this graph of this straight line, graph is symmetric about the origin of the coordinate axis. This is x-axis, this is y-axis. So at this origin 0, 0, at this point this graph is symmetric. Graph is symmetric about this point. So we have conclusion, or we have concluded our discussion into 3 points. Point number 1, if P of A B is equal to P of minus A comma B, then we say this is symmetric about y-axis. And if P of A comma B is equal to P of A comma minus B, any point, this direct P dash, any point giving its reflection like this, then we say it is symmetric about x-axis. And any point giving its reflection as minus A minus B, we say it is symmetric about origin. This is something as introduction. Now we take the application. We take an example. Suppose you have an equation 7y square minus 5x equal to 0. You want to study whether this graph or the graph of this equation is symmetric about x-axis or y-axis or about the origin. You want to study what is this graph shape like with respect to x-axis, y-axis or origin, whether it is symmetric about x-axis or y-axis or origin. Now what you have to do, take a point P with coordinate AB. So that means this equation will become 7b square minus 5a equal to 0. Let it be equation number 1. Now take another point P dash minus a comma b. That means this will become 7 of b square minus 5 of minus a. This becomes 7b square plus 5a. This is not equal to 7b square minus 5a. That means this is not equal. This is the object and this is the reflection. So these two reflections, these two are not symmetric. So therefore P dash is not symmetric to x-axis, sorry, to y-axis. Now if we take another reflection a comma minus b, put it over here, it becomes 7b square minus 5a equal to 0. Now this is equal to this. 1 is equal to 2. So that means this reflection is equal to the object. The coordinate of this reflection are equal. That means this graph or P double dash is symmetric to x-axis. And if we take another point, reflection point minus a minus b, this is equal to, put it here, minus b whole square minus 5 of this. This comes out to be 7b square plus 5a equal to 0, and this also is not same as P of AB. Therefore this point is not the reflection of P of AB. When it is not reflection, minus minus, then it is not symmetric about origin. So to conclude, this graph of 7y square minus 5x equal to 0 is symmetric about x-axis. Why? Because any point P AB is equal to P of A comma minus B, and P of AB is not equal to P of minus AB, and P of AB is also not equal to P of minus A minus B. So these are the three conditions. If it satisfies the first one, then it is symmetric about x-axis. It is not, so not symmetric. About y-axis, not equal, so not symmetric about origin. So to be symmetric about y-axis, it should satisfy P dash equal to minus A B. To be symmetric about x-axis, it has to satisfy P dash. To be symmetric about origin, it has to satisfy condition like this. Like this. So precisely any point on the graph gives you reflection, the same values, but only x coordinate becomes negative, then we say this graph is symmetric about y-axis. Now if it gives same values but negative of y coordinate, then we say symmetric about x-axis. Gives you same values but with both coordinate with a negative sign, then it is symmetric about origin. So this is something about symmetry of a graph, whether the graph is symmetric about x-axis or y-axis, about the origin. About the origin, you can also have a graph like this. Every point P will give you value of minus A minus B as the reflection. So all the points on this side will give you reflection with value of minus A minus B. So that is symmetric about origin. This is the origin. This is x-axis. This is y-axis. So symmetry is it is about the symmetric about a plane. About a plane. Plane is a reflecting surface. It may be a rectangular plane or it may be a point plane like this. Thank you very much for today.